Okay, Yefim gave an answer where X was the part of the wire that was cut into turned into a square. So I'm going to do it where X represents the perimeter of the equilateral triangle. Okay, so if X is the perimeter of the equilateral triangle, and each side is X over 3, and the formula for the area of an equilateral triangle is side squared times the square root of 3 over 4. And that all comes from the fact that if you drop an altitude here, you get a 30, 60, 90 right triangle. So this guy is half of the X over 3, and this side is radical 3 times this short leg of a 30, 60, 90. Anyway, it reduces to this. If we take 15 minus X as the perimeter of the square, then each side of the square is a fourth of that. So the area of the square is side squared. 15 minus X quantity squared over 16. There's the area function, where X is the perimeter of the equilateral triangle. If I take the derivative of that, we get radical 3 over 18 times X, and then 2 times 15 minus X, chain rule minus 1, over 16. 2 goes into 16 8 times. And if I distribute the negative 1, I get X minus 15. So there's the derivative. And we might make note of the fact that A double prime is radical 3 over 18 plus 1/8, which is always positive. So whatever critical number we get when we set this equal to 0, we'll be generating a relative minimum because the curve is concave up. So we'll set it equal to 0, multiply every term by 72 to clear the equation of fractions, factor out the X, take the negative 135 to the other side, and it turns out when X is about 8.47, we will get a minimum combined area. When X is 0, there's no triangle. So the area of the square will be 14.06. When X is 15, there's no square. So the area of the triangle will be side squared 25. 5 squared is 25, radical 3 over 4, which is about 10.8. So the maximum area is generated when there's no triangle, and the minimum area is generated when we split the wires such that X is about 8.47, which means that the perimeter of the square is that value minus subtracted from 15. There you go. Hope that helped. It didn't ask what is the actual minimum area, what is the actual maximum area, but you could plug this value into this function right here to get the maximum area. Okay, there you go. Hope that helped. If you have any questions, post a comment.